Now next topic, that is relation between angular momentum of a particle and torque acting on it. So we already discussed about angular momentum. We have the relationship of angular momentum with linear momentum, that is L equal to R cross P, or we can say this is the definition of angular momentum. Now differentiate this equation with respect to time t. So as per differentiation rule, we can write dl by dt equal to r cross dp by dt. So when two quantities are in multiplication, so here we can use the product rule of differentiation. So r, keep one quantity as it is, cross differentiate other one, dp by dt, plus differentiate first quantity dr by dt, cross keep other quantity as it is. Now here dp by dt, that is the rate of change of linear momentum, but that is the force acting on the particle, F. And dr by dt, that is velocity of the particle. So dl by dt, that is r cross F, and dr by dt, that is v. So second term, that is v cross p. P, that is mv, right? P, that is mv. So here we can say this thing, this v and p, m is scalar quantity. So v and p both are in the same direction. When both are in the same direction, then vector product will be 0. So this particular term will be cancelled. So dl by dt, that is r cross F, but as per definition r cross F, that is the torque acting on the particle. Okay. So dl by dt, that is r cross F, that is tau. So here we can say the rate of change of angular momentum is equal to torque. This one is in analogy with the time rate of change of linear momentum, that is equal to force, right? So you can observe the analogy with these physical quantities also. Now here one simple question arises in our mind. We discussed about the angular displacement, delta theta, right? Now we know this thing, arc, that is angle into theta, angle into radius, angle theta into radius. So theta, that is you can write arc upon radius, right? Means angular displacement that you can represent in terms of linear displacement. Then we discussed angular velocity, and we derived the relationship between angular velocity and linear velocity. It implies that angular velocity that can be represented as linear velocity. Then we discussed about torque. Torque have the analogy with force. Torque tau, that is r cross F, means torque can be represented with the help of force. Then angular momentum. So angular momentum can be represented with linear momentum. So when we have already the physical quantities, linear displacement, linear velocity, linear momentum, force, linear acceleration also, right? Then why we define these new physical quantities? Can you understand this thing? Why? Because if you think about the linear displacement, suppose I represent this thing with the help of figure. See, this particle, this is the reference point. Move from this position to this position. then we can say, suppose angular displacement is delta theta. But suppose we think about one another particle somewhere here. So it move on this arc, because this one is the rigid body, relative positions of the constituent particles never changes. See, angular displacement remains same one, but now linear displacement. So for this particle, this arc, for this particle, this arc, both are not same one. Means if you take angular displacement of any one particle, then that is the angular displacement of each and every particle of that rigid body, as well as you can say that is the angular displacement of entire rigid body. In the same way, linear velocity of each and every particle will be different one, but angular velocity of each and every particle and the entire body will be the same one. Similarly, linear momentum will be different one for each and every particle, but angular momentum will be same one. So you can say this thing, this angular displacement, angular velocity, then angular acceleration, then angular momentum, torque, all these physical quantities are the constants for the given rotational motion, and therefore we define these new physical quantities or parameters to explain the rotational motion properly in detail. Clear to all of you?